Hey, 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 I'm Anwar.
And I'm Jasmine.
And we are Tesla, teens exploring science with a live audience. Here's a picture of a Tesla coil. We named ourselves after Nikola Tesla because he helped us get a better understanding of electricity.
We are science achievers from the Community Initiatives team at the Museum of Science and Industry. This is a live call show at 5 o'clock p.m. every Wednesday.
And on this season of Tesla, we will be covering science gadgets and the people who use them.
Hey, what's a gadget?
Well, a gadget is a tool that you use to perform a specific task.
Oh, I know what a gadget is. I have a gadget in my pocket.
Oh, yeah?
It's my cell phone. I use it to text people, play video games, make phone calls. You know, it's a phone.
All right. Nice gadget, Jasmine. But we're going to be talking about science gadgets used in STEM careers. And these gadgets are going to perform a specific task.
What's a STEM?
Well, STEM is a shorter way of saying science, technology, engineering, mathematics. So we'll be covering science gadgets by people who work in these careers and use these gadgets.
But I heard that we are only covering up one science gadget.
And you are absolutely correct, Jasmine. But I'm really excited about this particular gadget because I want to be an electrical engineer myself.
Electrical engineers, but they use so many gadgets.
Mm-hmm.
Which science gadget are we talking about?
Well, the gadget that we are using is a test meter. It's actually called a multimeter.
What are we testing?
Well, we're testing batteries. Have you ever used batteries?
Of course I've used batteries. You know, I use batteries for my alarm clock, my cell phone, for my TV remote, for, many things.
Okay, we get it, Jasmine. You use batteries. Well, they help us power a lot of things.
Well, I have a question.
Hit me with it.
How do we know if a battery is actually good to use?
Duh. We use a multimeter.
How do we do that?
We will find out after this short break.
I'm tired. Hey guys, we're gonna be late for the STEM train. All aboard!
Hello everybody and welcome to the STEM train. I'm your host and conductor, Martin. And to my left and to my right, we have contestants who are going to be working together in order to try to unscramble a series of letters in order to find a word that represents a cool science gadget related to fields in STEM. So, are you guys ready?
Yeah!
Alright then, follow us onto the STEM train. Alright guys, so what is your name first of all?
Taylor.
Very nice to meet you, Taylor. How about you?
I am Victoria.
All right, let's give them a warm round of applause. And you guys are going to have 15 seconds in order to try to unscramble these letters into a word which represents a science gadget. So I'll give you guys a hint. It's a science gadget that is used in weather forecasting. So you guys ready?
Yeah!
All right. Well, 15 seconds on the clock. And you can start. Alright. Seems that the first letters are being picked out. Taylor has 3 letters already. Very interesting. Oh wow, so it seems that in even under 15 seconds, our contestants have been able to create a word. And in fact, what's more is that that is the correct word that we are looking for. So let's give them a big round of applause for that. Alright, so how'd you guys come about to, finding that this is the correct word?
Well, I know this is what the local weatherman uses in the mornings on the TV. When you're watching the news, we see him using the rain gauge. And I know that the local weatherman is a meteorologist, and that rain gauge not only collects the rain, but also measures it over a following period of time.
Well, that's wonderful. It seems that your insight has definitely brought some great success upon you. So that has been our first part of the STEM train, and just wait till the next break.
Hey everyone, and welcome back to Tesla. I'm Goldine.
And I'm Nidra.
And Nidra, I have an idea.
What's your idea?
So we have all of these batteries here.
Wait, I have a quick question. So how does a battery power electronic devices?
Well, a battery changes chemical energy into electrical energy, and the battery provides a push, or what we call voltage, to the changes in the wires and circuit.
Fancy answer.
Yeah.
But you were saying about the batteries on the podium?
Yeah, we can use the voltmeter function on the multimeter. Here it is. And we can check the voltage of all of these batteries here. And we check them to make sure they have enough push or voltage to power the device.
Like a TV or a MP3 player?
Exactly.
Cool. So this should be fun. But how are we going to use our multimeter?
Well, what we're going to do is we're going to test these batteries on the multimeter. So let's put the overhead on. All right. So here are our batteries. Let's get them all in here. So we have 3 batteries we would test. Sorry, here we are. All right, we have a 9-volt D battery, and a 1.5 D battery pack and then we have one that contains a 1.5 volt AA battery. So which one do you want to check first?
The big one.
All right, so the big one is a 1.5 D battery. So we're gonna use the DCV section. Let's take these two off. On the multimeter, and we're gonna turn it down to the number 20.
What does the 20 mean?
Well, 20 is the maximum amount a voltage the scale can read. So how do you think we do this?
Well, we take our 2 probes and place our black probe on the end where the black wire is connected, and the red probe on the opposite end where the red wire is connected. The red means positive and the black means negative. Now, read the meter.
Well, the meter reads 1.45. I don't think that's good.
No, it's not.
Yeah, the meter should read at least 1.5 because that's a good battery, right?
Exactly. So let's check the 9-volt battery next.
All right.
Which probe goes where?
Well, you said that the black is negative and the red is positive, right?
Right.
All right. Well, we have a negative sign here. So that means that the black probe goes here. And we have a positive side here. So that means the red probe goes here, right?
Right.
All right.
What does it read?
It reads 8.22.
So this battery isn't fresh.
Yeah, this should at least be 9 volts.
Exactly. So
All
let's
right.
get a fresh battery.
All right, sounds good. All right, we're going to open up a fresh battery.
It's
One
a little
second,
tricky.
guys. A little tricky here, but we're going to get it. Here we are. All right. So, since the black is negative, we have a negative side here. So we're going to place the black probe in the negative side. And the red is positive. We have a positive side here. So we'll place the red in the positive section. Let's get it to be.
What does it read?
It reads 9.54.
Well,
Wait,
this is...
let's make sure it's okay, 1 second. Okay.
Well, we can see it's around 9.53. So it seems like this is a fresh battery. And
Yes.
fresh batteries always read a little higher.
Yes, they should read about 9 point or more.
Exactly.
All right.
So now we have a battery pack holding 2 1.5 volt batteries. What do you think this battery pack should read?
Well, since it's 2 1.5 volt batteries, you would add 1.5 and 1.5 since it's 2, and you should get around 3 volts, right?
Exactly. So let's test it.
All right. Well, since this is a positive, we will put the red probe here. And since side is always opposite and the positive is on the bottom, we will put the black probe here. So let's check this out. It reads 3.22.
And this is a good battery.
Yes, because it's greater than 3 volts.
That was a lot of fun. Well, what else can we check with our multimeter?
Well, you're going to have to stay tuned after this break.
I'm tired. Hey guys, we're gonna be late for the snack train. All aboard!
Hello, everybody, and welcome to the STEM train. I'm your host and conductor, Martin. And to my left and to my right, we have contestants who are going to be working together in order to try to unscramble a series of letters in order to find a word that represents a cool science gadget related to fields in STEM. So, are you guys ready?
Yeah.
All right, then, follow us onto the STEM train. All right, guys, so what is your name, first of all?
Taylor.
Nice to meet you, Taylor. How about you?
I am Victoria.
All right, let's give them a warm round of applause. And you guys are going to have 15 seconds in order to try to unscramble these letters into a word which represents a science gadget. So I'll give you guys a hint. It's a science gadget that is used in weather forecasting. So, you guys ready?
Yeah.
All right. Well, 15 seconds on the clock. And you can start. All right. Seems that the first letters are being picked out. What do you think? Taylor has 3 letters already. Interesting. Oh, wow. So it seems that in even under 15 seconds, our contestants have been able to create a word. And in fact, what's more is that that is the correct word that we are looking for. So let's give them a big round of applause for that. All right, so how'd you guys come about to, finding that this is the correct word?
Well, I know this is what the local weatherman uses in the mornings on TV. When you're watching the news, we see that he's using the rain gauge. And I know that the local weatherman is a meteorologist, and that rain gauge not only collects the rain, but also measures it over a falling period of time.
Well, that's wonderful. It seems that your insight has definitely brought some great success upon you. So that has been our first part of the STEM train, and just wait till the next break.
Hello and welcome back to Tesla, Teens Exploring Science with a live audience. I'm Tyrone.
And I'm Tyler. So, Tyrone, are we going to have some fun today exploring cool things like voltage?
Well, you're close, Tyler. We're going to be exploring resistance because, voltage, we did that last segment. That's old.
Well, resistance sounds fun.
Yeah, it's really fun. So, we learned that batteries push the current through wires around a circuit.
Wait, I know this. The flow of charges in the wires, that's called electric current, right?
Correct. And in order to manage the current or the current at the desired rate, we use voltage to speed things up or resistors to slow things down.
Resistors slow a current down?
Of course. You don't want the current to overload your devices, do you?
No, not at all. Well, what do these resistors look like?
Well, you've come to the right place because, gersploosh. This is what a resistor looks like.
Tyrone, that's really tiny. Let's go ahead and throw it up on the overhead so our audience can get a better view.
Oh yeah, let's give you guys a better view of the resistor.
So you're saying that tiny thing can stop electricity?
Oh yeah, of course. And they come in different sizes in order to adjust the flow of charges known as current.
So can we have some fun now?
Oh yeah, tons of fun. Let's use the multimeter to check the sizes of these resistors. So here is the multimeter. And this time we're going to use the resistance section of the multimeter, which measures the resistance in ohms.
See, we can connect the probe to any end we choose. And today we have 3 resistors to test. One resistor at 620 ohms, another resistor at 8,200 ohms, and a final resistor at a large amount of 47,000 ohms.
Yeah, and the higher the number, the more it slows down the flow of charges or current.
Yeah, Tyrone, you're exactly right. So let's check out these resistors. Tyrone, go ahead, get that multimeter ready, and attach some alligator clips to our probe ends there.
Oh yeah, of course. We need alligator clips in order to make our testing easier.
Yep.
So I'm gonna attach red to red and black to black.
Black is for ground, red is for hot. Make sure you have that dial at 2,000 ohms to check the 620 ohm resistor too.
Of course, because 620 ohms is greater than 200 ohms, but less than 2,000 ohms.
Yeah.
Well, let's check out this resistor. Let's see what
Get a
this
read.
baby can do. And it looks like it's at 610 ohms. Wait, Tyler, did we get ripped off?
Yeah, you think that's kind of weird, huh?
Yeah, I mean, shouldn't it be 620 ohms?
Well, you see, the resistors are built in a range, so they can be a little above at like 630 or a little below at 610, where we're at right now. So that's actually okay.
Okay, so that means that this resistor is good since it's close to 610
Yeah.
or 620 ohms.
Yeah, absolutely. We could build stuff if we want to.
Oh, cool, cool. So this resistor is good.
Yep. So let's go ahead and check our next size at 8,200 ohms.
All right, let's check this out. 8,200 ohms. Wait, that means that we'll have to redo our dial to 20,000 ohms in order to get a reading on it, since, you know, we have a higher resistance.
Yeah, Tyrone, yeah.
Awesome. So let's check this. And it's looking to be about 8,040 ohms.
Still good.
Yeah, pretty good, pretty good, pretty good. Pretty close to 8,200 ohms.
Looks like we're getting some good resistors. No factory defects today, huh?
Yeah, yeah. Not like the batteries they did last segment.
So let's check our final resistor at, drumroll please, Tyrone.
Oh, yeah.
47,000 ohms.
Mike, wow. That's incredible. I'll have to change our dial to 200,000 ohms just to get a reading on it.
Isn't that crazy, Tyrone?
That's absolutely crazy. Well, let's see what we got here with this incredibly resistant resistor. All right, we're gonna attach this here and attach this to the other end. And 46,400 ohms. That's huge.
Well, that one's good to go as well. Another
Yeah.
perfect resistor. But the cool thing is, the 47,000 ohm resistor will slow the current down the most out of the 3 resistors we tested today.
Oh, that's cool. Wait, what makes you say that?
Well, you see, they're rated, so the higher you go up in number value, the more resistance you have. Kind of cool.
Yeah, that's awesome. So, well, there you have it. Stay tuned for more science gadgets after this break.
Welcome to our railway mail car. My name is Taylor, and I am your post clerk. And my job is to sort through all the mail and find really interesting letters about STEM gadgets. And I've sorted through a lot of really good ones, but this one is really interesting. This one is from John from Gillespie Tech. John wants to know why his doctor has a triangular-shaped hammer in his office. Well, John, the triangular-shaped hammer is actually a reflex hammer, and doctors use it to dissect certain problems in your nervous system. And they use it by testing something called the me reflex journey. Well, we love that you guys submitted your letters, and we want you guys to submit even more letters. So please, enter your questions at our Facebook page at MSI Tesla. Please provide your first name only and your school name. Thank you so much, and please come back right after this short break.
And welcome back to Tesla, guys. My name is Mike.
And I'm Alexis.
And, you know, Alexis, I think we should play a game.
Ooh, I do like games. So, what's the name of this game?
The name of this game is the Science Gadget Challenge.
Ooh.
Alright, so it's a pretty simple game. The way you play is each of us is going to take turns asking the other questions about what we've learned about today. And if you answer the question right, you get a point. The person with the most points at the end of the game is the winner.
Ooh, I think I'm up for this challenge. Let the games begin.
So, Alexis. Oh, we have our little handy-dandy scoreboard here. So, first question. What is the source of energy for your portable electronic devices?
Portable source of energy. That's a battery, Mike.
You are absolutely correct, and you get a point.
Yes, I do. All right. So, Mike, how does a cell get its energy?
Ooh, that's a tough one. So let's think this through. So a battery takes chemical energy and turns it into electrical energy.
Right.
And a battery is just a group of two or more cells. So that means that a cell must turn chemical energy into electrical energy.
Exactly. Point for you.
All right. So, Alexis, can you name the force that pushes charges through the wires in a circuit?
Ooh, the force that pushes charges through the wires. Mike, that's easy as pie. The force is called voltage.
You are absolutely correct, and I'm holding you to that pie.
All right. So, what component slows down the flow of charges through a wire?
What component slows down? Oh, easy. The component that slows down the electrical flow of a circuit would be a resistor.
Exactly.
All right, so here is a tricky one.
Okay.
What do you call a flow of charged particles?
Flow of charged particles. You almost got me. A flow of charged particles. Well, the charged particles are electricity, so a flow would be an electric current.
You know what? You are just too smart for me.
Yeah, I am. So, name this cool science gadget that we can use today to check voltage and resistance.
A cool science gadget. Oh, would it happen to be the only science gadget that we talked about on today's show?
Well, I don't give hints, but maybe.
Well then, the only gadget that we talked about today would have to be the multimeter.
You are absolutely correct.
Alright. So, when we tested our resistors, did it matter which sides the probes were on?
No, it didn't matter at all, because with resistors, both of the sides are exactly the same.
That is correct. You get a point.
So, Mike, when we tested our battery, why does it matter which sides the probes are connected to?
Okay, well, when you look at a battery, you see that it has a positive end and a negative end. And I know that the negative end actually repels electrons, and the positive end attracts them. So that must be why it matters, because the two sides of the battery are very different.
Indeed they are. That's a point for you, and it looks like we've tied, which means we are going to have a rematch. We're going to have another Science Gadget Challenge next week.
And you know what? I accept your challenge. Unfortunately, guys, this is the end of our show.
Oh, no.
Yeah, but no need to feel sad, because we will be right back here next week. So, guys, remember, we are MSI TESLA, that is Teens Exploring Science with a Live Audience. We are from the Museum of Science and Industry. We have a live call-in show every Wednesday here on CAN TV at 5 p.m. sharp. Be sure to check us out on the Facebook page. That is MSI TESLA, TESLA. And if you guys post your questions relating to science gadgets, hopefully we can address them during our next show.
Indeed. And we will see you all next week with more cool science gadgets.